going to show you how to use right-angled trigonometry to find a missing angle. There are three examples here, so fast forward through the ones that you don't think you need to watch. So as before, we're going to label sides in relation to this angle. This side here is opposite the angle, this side here is the hypotenuse. So we've got information about the hypotenuse and the opposite, therefore we're going to use sine. Now, you might know this formula triangle, or you might know sine of the angle is equal to opposite divided by hypotenuse. Either way, you would get the same formula, so the fact that you were trying to find the angle would mean you'd scrub out that part, cover that bit up, therefore you'd get opposite divided by hypotenuse. So we're going to fill out the missing information. We've got sine of x, that's the angle, is equal to the opposite side, which is 3, divided by the hypotenuse, which is 9. Now this is the funny bit with finding missing angle, is to get x by itself, you need to do the inverse of sine to bring it over this side. So inverse sine of 3 divided by 9. Put that into your calculator. To get inverse sine, you need to press shift, then sine. That should give you an answer of 19.47122063. Now, depending on how you're being asked to round, most likely to 3 significant figures, your final answer would be 19.5 degrees. Okay, looking at another example here, we should have another side labelled actually before we go on that, so we should have this labelled as 6 centimetres. So again, we're labelling things in relation to this angle. This side here is the adjacent side, and this side here is the hypotenuse. So we're going to be using cosine. So cosine of the angle is equal to the adjacent divided by the hypotenuse. We're trying to find the angle, so we cover that part up. Cosine of the angle equals adjacent divided by hypotenuse. Some of you may just know this formula, which is fine. So we're going to fill in the missing information. So cosine of the angle is x, so cosine of x is equal to the adjacent side, which is 6, divided by the hypotenuse, which is 14. Now again, we need to get x by itself on this side and move the cosine over here. So we do that inverse again, so cosine, inverse cosine of 6 over 14. Put that into the calculator, getting this by doing shift and then cosine. That gives us an answer of 64.62306647. Again, if we're rounding to 3 significant figures, which is quite common, that would be 64.6 degrees would be our final answer. Okay, final example here. Here's our angle. This side here is the opposite side. This side here is next door to it, so that's the adjacent side. So we're going to be using tan in this example. So tan of the angle is opposite divided by adjacent. That's a formula that you may know without having to use a formula triangle. If we're trying to find the angle, we cover that part up. So we've got tan of the angle equals opposite divided by adjacent. So if we fill out the information, the angle is x. So we've got tan of x is equal to, on the opposite side, which is 4, divided by the adjacent, which is 6.5. We need to get x by itself and bring tan over this side. So that's tan inverse of 4 divided by 6.5, which gives us an answer, if you put that in the calculator, of 31.60750225. So if you were having to round that, I'll have to do it up here because we've run out of room, probably to 3 significant figures. You should round it to 31.6 degrees. There's your final answer. Okay, so a few examples there of how to find an angle using right-angled trigonometry.